Wow, that doesn't work very well, does it, at the top? So sorry you can't see my colleagues here. Jim Houston is with us today, who has collaborated on this. Michelle Hughes, Frank Loth, Charles Vorster, and of course Mark Luciano. In fact, around 2013, Mark and Frank Loth and I sat down in a Starbucks and then a Whole Foods, who now has a new owner, and came up with these ideas for this research. And what we wanted to do was find out what are the cognitive effects, if there are any, in Chiari malformation with adults, and also why are there cognitive effects if they are? Are they due to pain? And are there changes in the brain that we can see that are associated with these cognitive effects? I should acknowledge funding from Conquer Chiari, and I will also apologize for not exactly talking about the title of this talk. It really isn't, the goal isn't to develop a test battery so much as to think of this in terms of a human performance endeavor and see what differs across these two groups, the groups being adults diagnosed with Chiari malformation and age and education match controls. I should note that that's really important to do for reasons that were mentioned earlier for children, because the norms for neuropsych assessment tests are based on a very different educational category than what your typical Chiari malformation patient presents with, which is usually at least 14 years of education or more. And if you're comparing someone with 14 years of education or even a college degree to someone without a college degree, then you have a compound with intelligence, most likely. So we want to start out with developing some familiarity with what tasks show effects on Chiari malformation, cognitive tasks, and also what happens when we compare experimental tasks with standardized tasks. And then finally, can we link these cognitive effects and pain effects to differences in fiber tracts between Chiari malformation patients and age and education match controls. So I don't think I need to talk about this too much, because most of you in this room know a whole lot more about this than I do. I'm an experimental psychologist. I am not a physician, and I am certainly not a neurosurgeon. But just for the fun of it, I do have comparisons. The person on the left, your left, is a Chiari patient, and the person on the right is control, and clearly there's a heck of a lot more crowding with the Chiari patient than the control. And I will say this, Jeremy, you made this research a lot easier with linking why you might expect a cognitive effect coming from something that is linked to the cerebellum. And that is your classic 1998 paper on cerebellar cognitive affective syndrome. And I also would like to say that dysmetry of thought is very poetic. So I will give you credit for that as well. And I suspect you'll like some data at the end of this, linking it to that as well. And you already talked about Buckner 2011. The key thing is now we literally have intrinsic functional connectivity from the cerebellum to so-called cognitive circuits, in particular the default mode network. And ironically, this isn't as pervasive, but there is a trend toward lobule 10 having connection to the frontoparietal attentional pathway. And lobule 10 are those pesky cerebellar tonsils that are getting in the way in Chiari malformation. Now, I think we've already heard enough about this one today too. The 2014 study, I'll just show you some pictures. There are group differences in almost everything. in cognitive performance. The rationale with this set of experimental cognitive tasks, where we looked at a Stroop interference task, a working memory task using an O-span task, a processing speed task, and then immediate and delayed recall, were kind of executive function, and then something else that has been mentioned several times by a lot of Chiari patients, that they have memory problems. Now, the big problem with immediate and delayed recall is whether it's an amnestic problem or whether it's an attention problem, where you actually encoded the stuff or you're having interference at retrieval. And quite honestly, we don't know the answer to that yet. But I can tell you with considerable certainty that there are large group differences between them in both immediate and delayed recall. That is, Chiari, adult Chiari patients and age and education matched controls. In this earlier study, it was limited to a sample of 24 Chiari patients who had undergone decompression surgery, and we didn't have the good control over them that we do in this new study that we're going to refer to today in more detail. We just tested them on this battery of cognitive tasks and compared them to controls. Memory was trending towards significance, but the so-called executive function tasks of processing speed, working memory, and Stroop interference showed huge group differences. And even when we partialed out an indicator for pain, the Stroop difference remained significant, but the others went away. And I would like to emphasize in this presentation that we are never quite sure in Chiari, when we see a cognitive effect, if it really is a cognitive effect, or what Mark Luciano has warned me of many times, that it's a chronic pain effect masquerading as a cognitive effect. And we're going to try to address that today as well. So in summary, we have this experimental evidence, at least on a small sample of people, that there are cognitive effects in Chiari malformation. Now, what we've done since then is to try to generalize this. And the first thing I wanted to address is there really a memory effect in Chiari malformation? Because that was ambiguous before. So what we did, we are now at the Conquer Chiari Research Center at the University of Akron. We are collecting data on a sample, self-report data, of people that have been diagnosed by a physician with Chiari malformation. This is self-report data. We do not have medical records connected to this, but so far close to 1,700 people have participated in this. We have complete memory data and a whole bunch of other fields for 638 of them. So this is a substantial sample. 341 of them have been decompressed, 297 were not decompressed. And we compared them to over 100 controls from past studies, and I would say controls loosely because we really stacked the deck. The controls here are a lot older than the Chiari patients. And we also used verbal auditory presentation for the controls and used visual for the Chiari patients. And I'm a memory researcher too, and that makes a huge difference. You perform much better with visual presentation most of the time in a recall task, and the controls blitz the Chiari patients. So we only have the immediate recall, and I should be specific here. We're using trial 1 of the RAV-LT, the Ray Auditory Verbal Learning Task. And we modify that and use trial 1 and trial 7 instead of all the learning trials. So we have immediate and delayed recall. And a whole lot of these other neuropsych assessment scales that we use today for immediate and free recall are variations on the RAV-LT. And being a cheap experimental psychologist, it's in the public domain, so that's why I use it, the RAV-LT. So there are group differences in immediate memory, and here's something else that might throw out a little hope as well. So we have immediate and delayed recall for the Chiari patients. And we found this interesting three-way interaction for delayed recall as the dependent variable, surgical group, pain level, and reflection level. Now, reflection is a personality variable in which it's really self-focused attention. And I perceive everything that a Chiari patient does with chronic pain as a dual task. Every time they try to process something, they are not only trying to do the cognitive processing, but they are trying to inhibit essentially a prepotent distractor, which is the pain response. And the question is, are we able to overcome the distraction to remember, either encode or retrieve the memory item? This three-way interaction occurred in a situation in which the non-decompressed patients who had low levels of pain but high levels of reflection performed better in delayed recall. Now, what we're essentially doing here is looking at ACT therapy. So we are getting people to overcome pain, and we're showing an improvement in cognitive performance. So that's the good news. The bad news is it doesn't even put a dent in it at high levels of pain. And here pain was measured with the McGill Pain Questionnaire, the short form version 2. So in fact, personality variables that affect self-focused attention can moderate the effect of group differences in the memory deficit. So again, it looks like a lot of the problem with cognitive performance is that pain is interfering with it. Okay, let's move on. Now we looked at the same thing with some EEGs, event-related potentials. Here we use the psychological refractory period task. And I think this is actually a good example of simultaneously a divided attention task, a focused attention task, and an executive function task. Because you have task 1 and you have task 2, and you vary the stimulus onset asynchrony between the two tasks, and then you see how task performance is affected by the SOA, or stimulus onset asynchrony, being varied. It's called the PRP effect. Guess what? There are no group differences in the PRP effect. That surprised us. We figured there might be. I do not think that Chiari affects all executive functions equally. It appears, in fact, that the most difficult of all of executive functions, which are, I would classify as an integration of focused and divided attention and really working memory, executive control, all put in together, we do not see group differences, either in reaction time, in accuracy, or in event-related potentials. Some EEGs using P100 or P300 waves. What we do find a difference, though, is that the Chiari patients are much slower. Furthermore, something else that fits in with Schmallmann's cognitive affective syndrome for the cerebellum is that there is an interaction with emotional valence. We use NIM-STIM faces for task 2, and in this case we had neutral, happy, and angry faces. And the idea is that angry faces initiate an amygdalar response, and we sure do not have enough time to explain how this works. But the idea is there's top-down amygdalar modulation in V2 of the visual cortex via the inferior longitudinal fasciculus that causes a larger an emotional effect on the threatening emotion than the positive. And Chiari patients don't show that at certain locations on the scalp, but the controls do. So here's your evidence that there is a fairly sophisticated affective deficit going on here. And furthermore, the spatial maps for the ERPs look a lot like aging for Chiari patients. It's called a frontal shift. So the denser effects go to the frontal cortex, which some people would argue is neural recruitment to try to compensate for that. Okay, so on experimental tasks, we have a whole lot of evidence that there are cognitive effects. But maybe Chiari patients can compensate for them partially by learning how to inhibit pain. But you could say, big deal. Is it clinically significant? Do we have pain really causing this? Or maybe do we just have such difficult, made-up laboratory tasks that in a clinical setting, they don't really mean anything? Well, we then tried this out on a sample of 20 Chiari patients that were candidates for decompression surgery and 20 age-matched controls. Later on, I apologize, but we only have 18 from each of those groups for the MRI data because 2 Chiari patients didn't feel up to getting the MRI. And it costs like $3,000 a participant, so we'll move it over to an upcoming study to use the rest. All right, let's speed up. On the R bands, we have immediate memory, attention, visual construction, language, and delayed memory. This is starting to sound like a recording, but we actually, Jeremy, have 4 versions of the R bands too, so it's very similar. The R in R band stands for repeated. It takes 30 minutes too, so it's a lot longer than Jeremy's new scales, but it also has been standardized and might be something that people could use, so we thought we would try it. The standard deviation is 15 on the R bands, and here are our results. The total scale score, the Chiari patients had significantly lower scores than the controls. In fact, everything but language and visual construction did not differ, and that's a real surprise because visual construction is a subcortical measure, and that's supposed to differ across the 2 groups. And Jim Houston was just talking to me before we did this today, and he was saying, well, there's a confound there because when you copy the figures, like Ray sorts of figures, it's the pattern that you match. But in fact, Chiari patients do make a systematic mistake. When you have a right angle and have to have a line halfway between the right angle, they will always cross over that right angle where the 2 lines go together to draw their line. So they do have some difficulty in processing some things. This isn't a sensitive enough test to measure. But notice here, immediate memory, delayed memory, and particularly attention show significant effects. In fact, attention is 1.5 standard deviations higher for the control group than the Chiari group. And it's over 1 standard deviation. The difference is 17 compared to 15 for 1 standard deviation for the total score. So I think one would be hard-pressed to argue that Chiari does not result for adults in a significant drop in standardized neuropsych test performance compared to age and education matched controls. I'm going to move on to the DTI part because starting back in that Starbucks in 2013, that was the real key here. If you have cognitive effects, what is causing them on the brain? So we've collected both DTI data and resting state fMRI data to look at intrinsic functional connectivity. I will show you some of the initial results from the DTI data just for clusters, not for ROIs yet. They kind of look like ROIs, but they're not perfect yet. So what have we found? So CM patients show higher levels of FA than controls for 2 clusters. You read that right. That is backwards from what I always thought, because I have a background in aging, and older adults always show lower FA than younger adults do. So the idea is, as you get closer to 1, you have more white matter integrity. We already heard this morning, though, that may not be the case, that it's more complicated. This paper down at the bottom, the Krishna et al. Paper, incidentally, that study has pre and post DTI, before and after decompression surgery, but they don't have behavioral measures with it. It was published in the Journal of Neurosurgery last year, the Krishna et al. Paper. The Krishna et al. Paper and the Kirtan et al. Paper also found higher FA for Chiari patients than controls, and it happens in hydrocephalus. And boy, I would love to hear from anyone in here that could explain why this is backwards from what it's supposed to be. The key thing is that it categorizes people. I will say this, that Krishna et al. Hypothesized that it was because you're getting compression, and that the compression is causing the fiber tracts to be pushed together more, and that's why you're showing higher FA values. Now, we found 2 clusters for FA in which the Chiari patients showed higher FA than the control group, and I'm going to show you pictures of those. In this sagittal section, you have the green cluster 2 and the red cluster 1. So even though that little cluster for the red one is much smaller, it actually shows a larger group difference. And just so you can see, that is on the left hemisphere in the cerebellum. And that looks to me around lobule 9, but we haven't done ROIs yet, so we don't know. So we do have these clusters. Furthermore, and I should also note that we actually did use the preferred method with FSL for doing the signal processing. So we are quite confident of our results, that we did not mess something up in the FA, because it's collaborated across all these studies. We used the Brzezinska et al.'s method. So in fact, we use TBSS methods in this. Now, here's what is interesting. We only have 18 in each group, though, instead of 20. When we link the data, the DTI data, the FA data, to the behavioral data, cluster 2 correlates with pain. Cluster 1 correlates with our band's attention data, which is, I think, a very impressive support for cerebellar cognitive affective syndrome, because you have a functional dissociation between the parts where you're seeing microstructural differences across Chiari and control in terms of what that does. Now, that green part looks like a pain effect. That red part so far is associated with a cognitive effect. So if people think, well, you don't have tissue damage from pain, that green area does suggest that there is tissue damage in Chiari with pain. So, let's revisit our criteria here. Familiarity with cognitive tasks associated with cerebellar functions. Well, There's an executive effect, an executive deficit in Chiari, except it doesn't include complex divided attention tasks. It does include processing speed, working memory, and particularly Stroop interference or inhibitory control. We do have immediate and delayed recall effects as well. And also, in our study with the large sample of 638 people, if we split them into people 40 and over and under 40, the people 40 and over showed poor recall. And these were all Chiari patients. We are already seeing what looks like an aging effect 20 to 30 years younger than we usually see it. So the question is, are there non-normative effects of Chiari that are showing much earlier cognitive deficits? And I would think that is something that we should very much want to look at as people interested in Chiari research, because this is saying that this group, which we didn't even diagnose until the mid to late 80s when we had a structural MRI to look at, they're already showing some things in their 40s that a lot of other people don't until their 60s. Also, attention has some effect, but not what we predicted. Also, we have standardized deficits in Chiari compared to control with standardized tests. And finally, and our brand new stuff that we just have analyzed, not only are these cognitive effects significant across groups, but they correlate with DTI effects for FA, and when you partial out the effect of pain, the McGill Pain Questionnaire scores, that effect for our band's attention is still significantly there in the cerebellum. So even when you partial out the effect of pain, it's still there. So this suggests not only are there pain effects, but they are linked apparently to fiber tract damage in Chiari malformation. Thank you. Yes.
Now I'm really confused.
Sorry.
The FA and DTI were not focused very well. I mean, there weren't specific areas. Most of the things were the entire cerebellum, right? I mean, it was the question I have for you is,
okay,
why are you specifying that this is a cognitive problem in the cerebellum, and you're looking at the entirety of the brain?
Well, first of all, the blue part is the part that there are no significant differences between the two groups. The green or red parts are the parts where there are significant differences in FA. Specifically, for FA, the Chiari patients have higher FA than the controls do.
And where, you said we haven't got this down yet, but is that near the compression of the cerebellum? Is that near the foramen magnum? It doesn't
actually, that is very close from what I can tell to lobule number 9, but a good question that I have no idea why this is why was it lateralized to the left side but not the right? So we will get to ROI stuff, but we also need to look at the white matter tracks, which is what you emphasize with DTI. But a lot of Chiari researchers also look at gray matter ROIs, even though there are a whole lot of white matter tracks in the cerebellum, so the level is high enough to actually pretend it's almost the white matter tract. But I don't think it's correct to say that you are looking at the whole brain here on these effects. The so-called pain effects are very widespread, but tend to really be focused around the genu area of the corpus callosum. Whereas the cluster that's significant with cognition is localized to the cerebellum. So there are usually two steps of DTI research in cognitive. And the first step is to look at clusters. And then the next step is to winnow it down to ROIs of anatomical structures. And we are just at the first step of looking at the more global clusters. So let's say we did a mathematical endeavor in which we just freed up FSL to find out all areas that were significantly different between these two groups. And to then do something like factor analysis and see if you have separate factors in which they differed in a different way. And that's exactly what you have there. Yes?
So you had said that you had patients that have had decompression and others that hadn't. Mm-hmm. Did you separate them out, or are they all just thrown in together?
Okay, in the study with 638, that was the case. In this study, this was a controlled study, the DTI study, in which we had 18 scanned individuals who were candidates for decompression surgery. In fact, every single one of them underwent decompression surgery within 6 months after this test. The two that we did not get were in so much pain that they could not participate in the MRI, and then were decompressed, and then they didn't fit the protocol anymore. So that's the problem with doing more control in your research.
So with those people that have now been decompressed, do you have any plans to go back and retest them to see what differences there may have been that have changed?
In a perfect world, yes. No, not in that one, but hold your horses here. We are planning a new one in which we're going to have 20 people before and after and do this with them and use 4D PCMR and that as well. Yes?
Did you take into consideration the high prevalence of sleep disturbances, sleep apnea, and how that may affect attention?
We actually have self-report data on that, because you really need sleep somnography to look at the apnea, and we just couldn't afford it in this study. But we have self-report data on that, and the sleep apnea self-report does correlate with cognitive deficits. I have not looked at it for this sample of 18 Chiari patients and 18 controls, though. Ironically, though, insomnia did not show up, but sleep apnea did, which surprised me. Yes?
I just want to quickly going back to the slide that had the R bands.
Sure.
Total scores. I just wanted to.
There. Sorry, there's so much there to go over.
It was very interesting. Yeah. So I understand that while you're talking about the differences between the groups, but as a clinical neuropsychologist, I just wanted to point out that I don't really see deficits per se, because even standard scores of like 90, low 90s is still in the average range, and as well as the attention is an 89.8, so that's just right low average. So
now let me
deficits, I don't know about.
Let me see if I can convince you of the incredible idea that I have here, which I may be dead wrong, but we'll see. You are comparing that to norms in which a 90 is based on a different group. You are seeing people here with almost 15 years of education on average that are showing 90s.
Right.
That's why I think this matters.
Right.
Because, and you cannot...
Because I'm just saying, like, somebody comes into the clinic, you know what I'm saying, and that's why it's difficult. That's why there's such a need to have more of these types of assessments that you're doing, because we're limited to looking at those norms and saying, okay, you're falling in the average range, but we know the patients are saying, but I don't feel normal and I feel like I'm having problems.
And so we are having people that are accountants or actuaries that are looking like someone with a severe deficit on a Stroop task, and that scares me.
Right.
Yes.
And in the DTI analysis, I guess you had to register to standard space
Yes.
all the subjects first.
Yes.
Did you get any problems registering a Chiari cerebellum to standard space? Because lobule 9 is not where lobule 9 the software thinks is going to be. So maybe
Well, let me
register to, yeah.
let Jim Houston answer this in the back here because he did the registration.
So what we did was we registered each image to each other and then registered the combined image set that was registered to each other to MNI space. And we added a second layer of it. It's an option in FSL. So instead of registering directly to an atlas, we registered to each other and then to an atlas. And we found that that gave us an improved registration. It was definitely a concern. This is actually our second approach to analyzing this data. We used a method before, and I won't name what we used, but it had a lot of trouble registering, so it may depend upon the software that you use as well. We use everything that we use is in the open licenses, GNU license, FSL, TVSS, it's all on their websites, kind of like a MATLAB type program where you pretty much do whatever you want if you got a good imagination. But yeah, we didn't have too much trouble in what we observed. Now, what we really want to do before we would publish this is deep project all of the areas in standardized space back into local space to make sure that it's lining up. We've done about 8 to 9 of them so far, and they've all been pretty spot on.
This conversation can go on for a long time. Congratulations on the work. You know, you're doing the clinical neuropsychology, you're doing the imaging in this patient population, coming up with new information. Innovative questions to go from here, so kudos to you. That was great. Thank you very much. So let's take a 50